Hello, my name is Jaypreet Singh, and the topic that I'm going to be talking about is electrospinning. Electrospinning is the formulation of non-woven polymer chains using a solution containing the polymer. This is done by putting the solution in a syringe and emptying it whilst a high voltage charge is applied. This breaks up the intermolecular forces, creating a singular strand and evaporating all of the solvent. The polymer creates a tailor cone at the tip of the syringe before straightening out as shown on the image on the right. The strand of polymer is then collected on a spinning wheel or drum, which is grounded to prevent charge buildup. In this video demonstrates how the polymer strands can be collected on the drum. The strands tend to be 10 nanometers in diameter. In this case, the strand is collected on a metal drum. When using this method, the width of the polymer can be kept constant to great precision. This method alters the properties of the polymer, which in result can make it stronger. Other chemicals can also be mixed with the solution and then electrospun. It is quite challenging to estimate the properties of the mixture when spun, as sometimes the polymer used breaks down in contact with such high voltage. Electrospraying is a similar method in which a higher voltage is used and the polymer exits the syringe as droplets as shown on the right. Electrospinning has many applications in the real world. They're used in the food industry to protect food. In one case, peptides with an antibacterial quality are used and electrospun with a polymer to create a bag which can protect food from bacteria as shown on the right. Carbon nanotubes can also be made from this method and can be used in hydrogen fuel cells and both solar thermal and solar PV panels, as carbon nanotubes are not only great at conducting heat and electricity, but have a high surface area to volume ratio. Electrospinning can also be used in textiles, as well as sometimes electrospun fibers can be stronger than steel weight for weight. For this reason, they are used for bulletproof vests and durable clothes. The fibers also can be spun closely in order to create a filtration net which you can use for a range of purposes. Electrospinning can also be used for tissue scaffolding. This is where the template is created so that cells can grow around in the right shape, such as the ears on the right. Fibers can also be used to close up wounds. An example of how it could be used is fibers could be spun straight onto the wound to act as a fibrous tissue. Layers of fibers can be spun to seal drugs inside to create a delayed release upon consumption, as the layer of polymer must be broken first before the drug inside is metabolized. Electrospinning has a relatively low startup cost. However, some of the materials and polymers are quite expensive later on. This method can be used for many different purposes. As soon as you change the polymer or the chemicals that you're using in the solution, the whole properties of the polymers change. They can be spun onto multiple other surfaces such as glass, metal, and water. Some of the disadvantages are there's not much research going into combinations. However, not all polymers work to high temperatures, as some of the peptides especially break down under high temperature. As I was saying before, the cost implications are quite high, roughly about £680 per gram of carbon nanotubes. And it is hard to get widths lower than 10 nanometers, as in the industry, 10 nanometers is used as a baseline. Thank you for listening.